Okay. May, June 2023, paper 6, variant 3. In question 1, the student determines the mass of a meter ruler by the balancing method. He uses the apparatus shown in figure 1.1. He has the load at the 5 centimeter mark, and then he has a pivot, and B is the distance between the pivot and the 50 centimeter mark. So I have two distances, A between the 5 centimeter mark and the pivot, B between the pivot and the 50 centimeter mark, which is supposedly the center of mass of this meter ruler. Soon places the circular load of mass 20 grams on the meter ruler, and he cannot see the position exactly. Can I determine from the numbers given, can I determine the position of the center of this load? Yes, I need to find the center of this load, which would be the average between the two distances, right? The center would be the average between the two distances. It starts at 6 and ends at 9. So can I find the difference? Can I find, I'm sorry, the average? Yes, it would be 6 plus 9 divided by 2. 15 divided by 2 is 7.5 centimeters. So this is the average distance between 6 and 9. The student places the meter ruler on the pivot and changes the position. He adjusts the position of the meter ruler on the pivot until the meter ruler is as nearly as possible to being balanced. Describe a technique for ensuring that the ruler is as near as possible to being balanced. One technique would be to balance the ruler. Yeah, that's the only technique basically. To balance the ruler but without the load. First of all, you need to find the balance of this ruler. You need to balance this ruler but without the load. Or you can say balance it without the load and make sure it doesn't tip to either side. So balance. Okay. Balance the ruler. Okay, until it doesn't tip to either side. For this question, we cannot say without the load. Why? Because he wants the center of the load to be at the 5 centimeter mark. Okay. So we need to balance it until it doesn't tip to either side. He finds the distances, as we said, distance A would be the distance between the pivot, P, and the 5 centimeter mark, so P minus 50, P minus 5, and B would be the distance between the center of the ruler, or the center of mass 50, and the position of the pivot, so 50 minus B. For the value of mass 20 grams, can I find the value of B over A? Yes, I can find B over A, which is 5.5 divided by 39.5, which is 0.14. 0.14. And then plot the graph. B, okay, so mass on the y-axis, mg on the y-axis, and b slash a on the x-axis, b slash a on the x-axis. The masses, you have 20 all the way to 100, 20 all the way to 100. So 20, 40, 60, 80, and 100. And then for B slash A, you have numbers values from 0.14 to 0.67. Okay, if we start with 0.1, can I start with 0.1? Yes, but you cannot add 0.1 each time. So 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, it wouldn't be enough. It wouldn't be enough. So you actually need to add 0.2 each time. You can start with 0.1 or you can start with 0 and then just add 0.2, 0.4, 0.6, and 0.8. It's not the best scale, but it's the only scale which would be okay for this graph, for this particular graph. Let's start plotting the points. So you have 20 and 0.14, 40 and 0.26, 20, 0.14, this is 0.1, 0.14, so it's at this point, 40 and 0.26, okay, 40 and 0.26, and then 60, 38, 80, 55. 60, 38. Where's 38? So this is okay, 38. Hmm. 80, 55. So I have 50, 55. This is over here. This is 55. And last point is 100 and 0.67. 100 and 0.67, which is right over here. So we need to draw a straight line. This is a straight line. And we need to find the gradient. Okay, can I draw the straight line? Okay. Hmm. This would be the straight line, the line of best fit. You have 1 point or 2 points above and 2 points below, which is okay. It's acceptable. 2 points above and 2 points below the line. And then, can I find the gradient? Yes, I can find the gradient. Y2 minus y1 over x2 minus x1, but you have to show it on the graph by drawing the triangle method. Draw the triangle method, and then calculate 100 minus 20 over 0.67 minus 0.14. This would give you a value of 150.9 or 151. This is the gradient, right? The gradient would be 151. Can I find, next question, next question. He's saying the mass of MR, let me remove this line. Okay, the mass of MR is equivalent to the gradient. It's the same value. Can I include the unit of the mass? It's grams, so basically 151 grams. It is the same value. Hmm. The determination of MR by this method assumes that the center of mass is at the 50 centimeter mark. So just how you could use the apparatus to test whether the center of mass is at the 50 centimeter mark or not. This is when you say we need to balance it without any balances, without any masses. Balance the ruler without any masses. Balance the ruler without any masses. Make sure it doesn't tip over as well. Student finds that the center of mass of a meter ruler is at the 48.7 mark. So it's not exactly at 50, it's at 48.7. Suggest how she changes the procedure in BII. What was the procedure in BII? In BII, she assumed that the center of mass was at the 50 centimeter mark, and therefore she calculated the distance B. How did she calculate the distance B? By saying 50 minus P, or whatever the point of the pivot, or wherever the pivot is, right? She calculated 50 minus P. But now the center of mass isn't at the 50 centimeter mark, it's at 48.7. So you just need to simply change this equation. Instead of saying 50 minus P, you'll say 48.7 minus P. So B would now be equal to 48.7 minus P. Fine? Okay. Now, moving on. A student investigates a circuit containing different combinations of resistors. A circuit A is not yet complete. On figure 2.1, complete the circuit to show a voltmeter. Can I draw a voltmeter? Yes, I can draw a voltmeter parallel to you. So this is the voltmeter. You have several circuits. Circuit A, now the circuit measures the potential difference across U and the current. What is the voltage and what is the current? The voltage is 1.7 volts and the current is 0.42 amperes. Okay. Circuit B, you have two resistors in parallel. Circuit C, you have three of them in parallel. She connects two 3 ohm resistors, and then she repeats the experiment with 3 ohm resistors. Okay, three of these 3 ohm resistors. For each circuit, she measures the potential difference in U as seen in the table. Can I find the resistance for each of these combinations? Yes, I can find the resistance. R equals V over I, so 1.7 divided by 0.42. Okay, and she repeats the experiment. So for the first resistance, it would be 4.05. 4.05. And then 2.1 divided by 0.54. 2.1 divided by 0.54. This is 3.89. And the last one, 2.4 divided by 0.63. 3.81. 3.81. Okay. This suggests that the values of R should be the same. Are these values the same? You have 4.05. Okay. You have 4.05 and 3.89, 3.81. Are they the same value? They seem to be close. We need to determine the value using the percentage error, using the division method. 4.05 divided by 3.89. What was 4.05? Okay, 0.05 divided by 3.89. This is 1.04, right? 1.04. So only 4% difference. Very close, yes. What about if I divide the 3.89 divided by 3.81? 0.89 divided by 3.81. 1.02. Definitely acceptable, right? 4% and 2%. They are acceptable. So the statement, yes, they are the same. Yes, they are the same. Why? Because the values 4.05, 3.89, 3.81 are close and within the limits of experimental accuracy. Okay, the limits of experimental accuracy. Okay, student determines the resistance of a resistor U using a variable resistor to control the circuit. Can I draw the variable resistor? Yes, I can draw the variable resistor. Briefly explain one advantage of using a variable resistor instead of adding resistors. So what she did in circuit A and B and C was that she kept on adding resistors in parallel, right? And as she adds the resistors in parallel, the resistance should decrease, the overall resistance should decrease. Why would using a variable resistor be more useful? Because it's a lot easier and it would give you a lot more values. So for example, now she had only three values, right? The variable resistor could give her way more values, right? Could give her way more. So it's a lot more easier to get more variables, right? It's easier to get more values. Soon suggests that the potential difference and the current are proportional. Suggest how a graph would show that these values are proportional. Any graph that shows a direct proportionality between two variables has two conditions. The two conditions must be satisfied, which are that it passes through the origin, passes through the origin, and it has to be a straight line. It has to be a straight line. Okay. I don't know if this is an and or not, but let me repeat it. Okay. And it is a straight line. In question 3, we have a ray trace sheet with mirrors. Okay. Okay, we have two mirrors. And then the student places two mirrors FE at an angle of 100 degrees to each other. On figure 3.1, draw normal FG. Normal to FG. At point N, extend the normal below FG. Label the lower end L. So at point N, you need to draw a normal perpendicular to this mirror, which would look somewhat like this. So this is your normal. Again, you're using a ruler. You have to make sure that this is 90 degrees. It has to be exactly 90 degrees. Okay, this is the normal. And the lower end, this should be L, normal line, NL. Okay, have normal at this point. Next question, he's asking me to find the angle theta. Can I find this small angle? Can I find this small angle theta 1? Yes, I can find the small angle theta 1 using the protractor. This angle would be 15. Right? It's a very small angle, which is 15 degrees. If your value is 16 or 14, it could be acceptable. Okay, could be acceptable. Student places two pins P1 and P2. Measure the distance between these two pins. Measuring the distance between P1 and P2. It's quite a small distance, which is 3.5 centimeters. If your value is slightly less due to the printing, which is okay. Okay, this is a printing error. It's not an error in your reading or anything. It's due to the printing error. So the distance, it should be 3.5 centimeters. If your value is slightly less, 3.4 or 3.3 might be acceptable. Suggest whether the two pins are at a suitable distance or not. Even if the distance is exactly 3.5 centimeters, is this a suitable distance? It is most definitely not. Why isn't it a suitable distance? Because it's too close. Okay, so it's not suitable. Not suitable. Why? Because too close. Pins are too close. Distance must be, we know that the distance must be at least what? We memorize the number, it must be at least 5 centimeters. At least 5 centimeters. Soon to use the images P1 and P2. Draw a line through P3 and P4. Extend the line 10 centimeters above FE. You have to be very accurate while measuring the distance above FE. So you have P3 and P4. Draw the line from P3 to P4 using the ruler, definitely. Okay, P3 to P4. And then extend it 10 centimeters above FE, so until it reaches FE, right? And extend it 10 centimeters. So you have to measure from this point 10 centimeters. Okay. This is all a straight line above FE until you reach this point. 10 centimeters exactly. Label this end, this upper end R, and the lower end B. Lower end is B, and the upper end is R. Okay, that was easy. She repeats the experiment, theta 2. Draw the line P5 and P6 until it reaches BR. Upper end T, lower end C. Okay, so P5 and P6 all the way until they reach. Again, you're using your ruler, so this has to be a straight line. Let me remove this, draw it again. Okay, this has to be a straight line until it reaches BR. The upper end is T, right? And the lower end is C. That's what he said. Yes, and then measure the angle between these two lines. T, lower end is C. I need to measure the angle theta between these two lines. Alpha. Can I measure this angle alpha? Yes, I can measure the angle alpha. This angle would be rather small. I guess it's 27 degrees. If your angle is slightly less or slightly greater than 27, it would be acceptable. So this is 27 degrees, right? Not bad. Sunt thinks that there is a relationship between alpha and the values of theta 1 and theta 2. Is this the case? Let's see. Alpha was what was 27 degrees, right? Theta 1, what was theta 1? It was 15 degrees. It was 15 degrees. What about theta 2? Hmm. Theta 2 was 40 degrees, right? This is theta 2. Is there any relationship between these two values, between these three values? Hmm. Someone might say, if you add 27, 15, if you add 27 and 15, this will give you a value of 42. And if your values are slightly off, for example, theta 1 was 16 and alpha was 26, and if you add them, it would be exactly 40. So there is a relationship. Yes, there is a relationship between them, which is basically alpha plus theta 1 would be equal to theta 2. Alpha plus theta 1 would be equal to theta 2, right? Why? Because we said 27 plus 15 is equal to 42, which is very close to 40 within the limits. Yes, it is within the limits. 42 divided by 40, 1.05, 5%. Definitely within the limits. So the values are close and within the limits of experimental accuracy. Right? Okay. So just two precautions. Two precautions in this experiment would be to use thin lines, and view the bases of the pins of the pins. Suggest one reason why different students all doing the same experiment may not obtain identical results. So if different students do the same experiment, sometimes they might not have the same results. Why? Because they haven't used thin lines or thin pins. That's why one of the precautions is to use thin lines. Okay, so the lines, and pins, okay, were too thick. Need to use thin lines and thin pins. Hmm. Question 4. Student is investigating the rate of cooling of hot water which has a lid, and a beaker which has a lid. Plan experiment which will enable him. It will enable him to compare the effect of the lids of different thicknesses. Of what? Of different thicknesses. So you need to change the thickness. I've already solved the question, right? Because you already have the range of values. You already have the independent variable, which is the thickness of the lid, right? The thickness of the lid. So I can start off by writing down the range of values. Okay, the range of values, which is the thickness of the lid. The thickness of the lid. And I need to state several values for this thickness. You can say 2 centimeters, 4 centimeters, 6, 8, and 10 centimeters. 5 values at least. 5 different values. Now you have apparatus, beaker, supply of hot water, insulating material. Basically, you don't have enough apparatuses. That's why he has to tell me, okay, I need to include the missing apparatuses, and I need to state the key variables. What are the key variables, the controlled variables for this question? The controlled variables. What would the controlled variables be? For example, I have a lot of them. This is a very common question. The volume of the water, the initial temperature of the water, and then you can talk about the room temperature. And for this question, you need to find the rate of cooling, right? So as you're finding the rate of cooling, you could either say that the time taken is constant or the final temperature is constant. Either or. Okay, you cannot say both. You cannot say both. So for this question, you have to say, for example, I'd like to say that the time taken is constant. The time taken. is constant. Therefore, the final temperature would vary, and we would calculate the rate of cooling based on the final temperature. What about the missing apparatuses? Apparatus. So he hasn't written down a thermometer nor a stopwatch, and we might need a ruler, right? You might need the ruler to measure the thickness of these lids, right? Don't need to write down any precautions. Let's go on and write down the steps. Okay, how can I conduct this experiment? Hmm. As so, you need to add water. Add water to the beaker. Add the lid. Okay, add the lid. Leave the water for a fixed amount of time. Leave the water for a fixed amount of time. Okay. Measure the final temperature. Final temperature and calculate the rate. Calculate the rate of cooling. And repeat and take average. Repeat and take average. Okay, so I've written down the steps. What about the table? Can I draw the table in this empty space? Yes. Okay, table. You can have several columns. The first and most important column would be the thickness of the lid in centimeters. To find the rate of cooling, you need three things: the initial temperature, the final temperature, and the time taken. I know that the initial temperature should be constant, but I'll write it down anyway. Initial temperature in degrees Celsius. The time is also constant, but I'll write it down. The final temperature is variable. This is the dependent variable in this question. Can I write down a conclusion? How will I reach a conclusion? Okay, for the conclusion, for each reading, for each thickness, repeat the experiment and take average. Okay, and take average. Record the readings in the table. Record the readings in the table. How can I compare the results? Compare the results by drawing a graph or by plotting a graph. By plotting. This should be plotting, but somehow I have messed it up. Plotting, okay? Of the thickness versus the rate of cooling.